Hi, welcome. Today we want to talk a little bit about, we want to find a way to visually think about logic. And the best tool to do that is a thing called an Euler diagram. Now you remember Euler, very famous mathematician, contributed lots of stuff to algebra and other aspects of mathematics. But we're going to use a technique that he developed uh, to make these things more understandable. So our objective today is just simply to figure out how to use these Euler diagrams. Now, you guys all agree, I think, that sometimes it's easier to understand a picture than to understand the words. And so what we're going to do is we're going to try to imagine what these sets would look like if we tried to draw pictures of them. So let's look at this first one right here. Okay, this one right here. This says that all A are inside B. So A is a subset of B. That's pretty simple. This one over here, this one tells us that A and B are completely separate. There's nothing in A that's also in B, also nothing in B that's also in A. So these are two separate sets. These are disjoint sets. They have nothing in common. Now, let's look at what we got down here. Okay, the third group here. This says some A are in B. This is the area in here. See this little football-shaped area? This is the area of all the things that are in A that are also in B. So that's the intersection. Okay. So if I say some A are in B, this is what it looks like. It's got an area in here that's in A and it's some at the same time in B. Now if we change it and we say some A that are not in B, then we have this model. Okay, so in this model, this is the area that's in A. So that's the area that's got to be, that at least one of the elements has got to be in. I apologize for that lousy drawing. But anyway, you get the picture. This is the area that's in A, but not in B. So what we're going to try to do is to draw pictures of how this logic works. So how do we do this? First thing, make an Euler diagram for the first premise. We've got two premises to work with. So make a drawing, make a picture of the first premise. Then make another picture for the second premise on the same sheet that the first premise is on. Now, the argument is valid if and only if every possible diagram illustrates the conclusion of the argument. So let's talk about what that means. Okay. All people who arrive late cannot perform. Okay, how would we draw that? All people who arrive late cannot perform. All people who cannot perform are ineligible for scholarships. Therefore, all people who arrive late cannot get a scholarship. Okay, all people who arrive late. Okay, imagine that you're in you're a music major and you have to show up for a performance. And based on the performance, you're either going to get or not get a scholarship. So the rule says if you arrive late, you cannot perform. And then the second rule says all people who cannot perform cannot get a scholarship. Therefore, all people who arrive late are ineligible for scholarships. Okay, let's see what that looks like. Okay, make the Euler diagram for the first premise. Okay, here's the people who cannot perform. Here's the people who arrive late. Okay, and it says all the people who arrive late cannot perform. That's what that looks like. Okay, now look at the second premise. What's it going to look like? Okay, the people who cannot perform are ineligible for scholarships. So what that means is that anybody who's in, of the people who are ineligible for scholarships, some of them cannot perform. And all the people who cannot perform are ineligible for scholarships. Now, can you conclude from that that all people who arrive late are ineligible for scholarships? Well, clearly you can, because the arrive lates are completely inside the ineligible for scholarships. So you see, this helps us visualize what this logic looks like. And sometimes the visualization is really useful. Let's try this one. All poets appreciate language. All writers appreciate language. Therefore, all poets are writers. Well, let's try that. That kind of worries me. Okay, so here's the people that appreciate language, and here's the poets. All the poets appreciate language. So they're completely contained in the group that appreciates language. Now let's look at the next set. Well, move forward. There we go. Now, all writers appreciate language can be done in one of four ways. Either this one, here's all the people who appreciate language, and here's the poets, and here's the writers. Now, it could be that there's some writers who are also poets, so they live in this world. So we could put them right in here. Now here it says, okay, all writers, all poets are writers. This one says all writers are poets. Now, which one did we say? Well, not all diagrams illustrate the argument that says all poets are writers. The first two certainly don't, so the argument is invalid. For it to be valid, all images have to completely contain it. So how about this one? All people are mortal. Some mortals are students. Therefore, some people are students. This one's pretty simple. Here's all the mortals. Here's all the people. Okay, those of you who are big fans of some of those science fiction shows out there that have the immortals, well, they would be out here somewhere. So the immortals are out there. Here's our mortals. Here's our people. Now, it says some people are students. Okay, some people are students. Okay, how would that look? Well, some people are students means that there's an intersection between the students and the people. So then can we conclude that some mortals are students? Well, yeah, because right in here, we've got the area of mortals that happen to be students. Does that make sense? So there's our model. If we can find a place that they overlap, at least one mortal is a student, well, there's the area of students who are also mortals. If that exists, we say it's true. So the argument is valid, if and only if the diagram concludes that that's what we were talking about. This diagram does not show that the people circle and the student circle intersect, so the conclusion does not follow. See, what we've got is mortals can be students, but we didn't really find out if people can be students.